Welcome to Miss Smith Math Tutorials. I'm Miss Smith. In this video we're going to be talking about solving exponential equations, and it's a pretty simple process in that you follow kind of some basic steps. So the first step is you make each side of the equation have the same base. And as a quick review, a base, I've drawn a little diagram over here, your base is going to be your large number or variable, and the exponent or the power is the tiny one up in the right corner. Okay, so anytime we refer to the base, we're talking about this part. So we want to make each side of the equation have the same base. We also want to, as our next step, remove the bases once they're the same and set the exponents equal to each other. From there, it's pretty easy. We just solve for the unknown variable. We just use our basic solving algebraic steps. So kind of with everything, it makes the most sense once you get into it and start doing examples. So for this first example, notice our step one was to make each side of the equation have the same base. So notice on either side of the equal sign, my base, the large number or letter, is the same, right? This one is a 2 and that one is a 2. So I can already skip step 1, that's done. These have the same base. And for these first two problems, they both are going to have the same base. We'll get into on our next sheet what we do if we don't have the same base. But these are the pretty easy examples. They're already done. Okay. Number 2, remove the bases, set the exponents equal to each other. So we want to make these bases of 2's disappear. So you can, some teachers will do this, like a little mark out, right? So we're getting rid of the bases, we're dropping the bases, and instead we're just going to have the exponents. So 3x minus 2 equals 2x. And then step 3, solve for the unknown variable. So in this case, my unknown variable is x, and I'm just going to use my basic solving skills for this. So I want to get my x's together. So I've got 3x on this side, 2x on this side. So I'm going to take the bigger, or excuse me, I'm going to take the smaller and move it to the bigger. I'm going to subtract 2x from this side, same from that side, and 3x minus 2x is just x. I've still got this minus 2 equals 0, right? 2x minus 2x is 0. And then I would want to add 2 to both sides. And x equals 0 plus 2 is 2. So here is my final answer. You do always want to take the time to check your answer, and you can use a calculator to help check it really quickly. So I'm going to bring out my calculator to show you how we would do that. So if we know x equals 2, based on our solving, we can plug that into the original equations for x, and we should get a true statement. So in this case, our base of 2 to the power of 3 times x, but it's not x anymore, we're calling it 2, right? So 3 times 2 minus 2. Let me see what I get. I get 16. So now if I do the other side, I should also get 16. So 2 to the power of 2 times x, but it's not x anymore, now it's 2. And I do get 16. So that just is reassuring for me that I did the right thing. We did all of our solving correctly. Let's look at another example. So over here, this one looks a little different because we've got some multiplication on this side. But if you notice, when I check to see does my equation have the same bases for that step 1, notice this one has a base of 5, and a base of 5. So I'm actually good to go. I don't need to make them have the same base. They already have them. So I can move on to step 2. Remove the bases and set the exponents equal to each other. So because these are all 5, it's kind of like you can just knock out the 5s. And then here's where I have to remember my exponent rules. Okay, now if you need a refresher, if you're like, exponent rules, what do you mean? What are laws of exponents? You definitely are going to want to go back and review my videos on the laws of exponents. I have, I think, 3 videos going through the rules, and then I have one where I do just a ton of practice problems, but you're going to want to make sure you have those down first. You would remember that when we multiply like bases straight across, what do I do with the exponents? I add them. Okay, so when we multiply with like bases, we add the exponents. So I'm going to follow that same rule here. So since this is 5x times 5x plus 2, these two are really being added together. So we would write that as x plus x plus 2. This one plus this one equals, and then I've got my exponent over here, 4x minus 10. Now I'm just back to my basic solving we've been doing forever. X plus x is 2x plus 2 equals 4x minus 10. I want to take my smaller x value and bring it to the larger x value using my inverse operation. So I'd want to subtract 2x. So I've got 2 equals 4x minus 2x. That would give me 2x minus 10. And of course I want to, now that I got my x's all on one side, I want to get my constants all together. So I'm going to add 10. 2 plus 10 is 12 equals 2x. And then my final step to get x alone is I need to divide by 2, and x equals 12 divided by 2 is 6. Notice I just flipped that there. I can do that. It's no big deal. I kind of just naturally do that because I like seeing x on the left, but x could be on the right. This could read 6 equals x. That's fine. It's just a habit for me. So we've got x equals 6. So now you can always double check your answer by taking the 6 and plugging it in here, here, and here, and we should get a true statement. And to just show that, I can quickly show that. So we would take our 5 to the power of x, but it's not x, it's 6, times 5 to the power of 6 plus 2. When I hit enter, I get this long number. That's okay. When I do this side, I should get the same number. I should get a matching answer. So we're going to do 5 to the power of 4 times 6 minus 10. And look at that. Even though it's this long answer, that's okay. I got the same one each time, which means this is a true statement. This now equals this if I'm putting in 6 for x. Let's look at some additional examples. So looking at this first one, you hopefully immediately notice something, and it's that we don't have the same base here. So on the other side, on the other page, we had all like bases, but here we do not. That's okay. We just need to follow that step 1, which was make each side of the equation have the same bases. We got to kind of skip that step on the first 2. But here, I don't have the same bases. So a good place to start is to start with your lower base. So in this case, I've got 6 would be my lower base, right? 36 is higher than 6. So I would always start with 6, and I would say, can I make a base of 6 over here? Now, obviously, I'm going to have to put an exponent with it, but is there anything that's 6 to the power of something that would give me 36? Now, some of you may know, yeah, 6 squared is 36. 6 times 6 is 36. But let's pretend you didn't know that, because sometimes it's not as easy to see. So I'm going to show you a trick using the calculator of how we can figure out what my base needs to be. Now, I do need to have a starting point. So in this case, my starting point, my kind of guess, my possible base would be 6. So if you go into your y equals, and we put in that base of 6 to the power of x, we're going to look at every possible value that could come from that scenario. So let's see, we're going to hit second graph. This takes us to our table. So the way we would read this, the way I have that y equals set up, is that 6 to the 0 power would give me 1. 6 to the first power would give me 6. 6 to the second power would give me, ding, 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 exactly what I need, 36. So that tells me, okay, I know 6 to the power of 2 is going to give me, be equivalent to that 36. So the way we would write that is my same base is going to be 6. So I'm going to go ahead and just bring down this side. 6 to the 4x plus 10 equals, and then I want my new base to be 6, and it's 6 to the what power? Second power, right? Because 6 squared is 36. So you see how I created something equivalent so that now I have like bases. Now that I have like bases, I can go on to step 2, which is drop my bases, remove them, right? And then set the exponents equal to each other. So this is 4x plus 10 equals 2. And then I solve for x from here like normal. So I would want to subtract 10, and I get 4x equals 2 minus 10. That's going to give me a negative 8. And then when I divide out to get my final answer, I end up with, I'm going to just write it over here, x equals negative 8 divided by 4 is negative 2. We could take the time to check it, but if you plug in negative 2 here for x and you put that in your calculator, you do get 36. So you would know your answer is correct. So take the time to do that if you want to practice it, but I'm going to keep moving. Let's look at another example. In this one, I've got a base of 4 with an exponent of x minus 7, and that's set equal to a base of 64 with a x plus 2 exponent. So in this case, remember our strategy is going to be very similar to the last one. So start with the lower base. That's a good just starting place because I already have one base of 4. So let me see, is there any way I can get 64 to have a base of 4? And remember our steps for doing that. Let's pull out our calculator. This is very helpful. We cut it on, we get our y equals, and we want to look at a base of 4, and we want to see, is there any way I can do that and end up with 64? So let's try it. 4 to the power of x. I'm putting in x. Second graph to look at my table. So looking at my y equals, do you see how there's a 64 there? That's exactly what I would want to see because I want to end up with a 64. So what would I have to put 4 to the power of? 3. So that tells me 4 cubed, 4 to the third power, is 64, which is exactly what I want. So I know the base of 4 is going to work, so I'm going to go ahead and bring down this side. So 4 to the x minus 7 equals, I know my base is going to be 4, and we said 4, the equivalent of 64 is 4 cubed. But here's where I've got to be careful. 64 is 4 cubed, but I still have this x plus 2 up here. It doesn't just go away, right? We've got to incorporate that into this. So we've got to reach back into those exponent rules. And if you remember, what happens when we have a power brought to another power? We call that the power to power rule. And it means that we multiply the powers. So this isn't just 3, it's really 3 times the original power, x plus 2. And that is my new power. So notice I've got like bases now, 4 and 4, so I can go ahead and remove the bases and bring down the exponents. So x minus 7 equals 3 times x plus 2. And I would solve this as usual. I've got parentheses there, so I need to definitely distribute that 3 to the parenthesis set. So I've got an x minus 7 here equals 3 times x is 3x. 3 times 2 is positive 6. I want to get my x's together, so I'm going to take the smaller and move it to the larger. So I'd end up with negative 7 equals 3x minus x. That's going to give me 2x plus 6. And I'm running out of space a little bit. I don't want to cramp my next problem, so I'm going to bring it up here. I'm just going to bring that right up there, and I'm going to keep solving. So I want to get my constants together. Negative 7 minus 6. That's going to give me a negative 13 equals 2x. And my final step, of course, is to divide by 2. I always like to write my x on the left, so I'm going to go ahead and do that. X equals negative 13 divided by 2. Ooh. Is that okay? Is it all right to have a fraction? Absolutely. Okay, and if you don't like fractions, you'd rather deal with the decimal. Sometimes it's easier to do a decimal. This would be negative 6.5. Right, so either one, totally fine. So this would be our answer, right, in either the decimal or the fraction form. And I can absolutely plug this in for x here and here and get true statements on both sides. So take the time to do that. Definitely if you're doing a quiz or test, for sure take the time to do that. But here I'm gonna, for the sake of time, I'm gonna keep moving. On this one, I've got 4 to the 5x power equals 8 to the 2x minus 1 power. So remember what I've taught you. We don't have like bases, so we need to make like bases. And in this case, remember I said start with the lower base just to test it, because that's always the best place to start. So in this case, I've got a 4. So I'm going to say, let me see, can I make this 8 have a base of 4 to the power of something so that it's equivalent to 8? So calculator is super helpful with this. Go to your y equals and type in, remember our suspected base is 4. So I want to see, would 4 work? 4 to the power of x. Let's go in the table and find out. Okay, so remember I'm looking over here in the y. I want to know, could I get an answer of 8 with a base of 4? And here's the thing. Notice there's no 8 there. Okay, it goes from 1 to 4 to 16. There's no 8. So the answer is no. So in this case, my base of 4 is not good enough. I need to figure out now, okay, well, what can I make the base of 4 into? Well, hopefully you're thinking the only thing that's going to go into 4 is going to, other than 1, is going to be 2, right? So I bring my calculator out and I do my y equals 2 to the power of x. So right now I'm testing a base of 2. Would 2 work to give me 4? And would 2 work to give me 8? Right, so let's see. Let's go into the second graph. We're looking in our y column, and look, I see a 4 and I see an 8. That's exactly what I need. So I know what my base needs to be now. It needs to be 2. Okay, and then I'm going to use, so it needs to be 2 squared on this side to give me 4, and it needs to be 2 cubed on this side to give me that 8. Okay, so let's go ahead and rewrite this. So this is now, instead of 4, it's going to be a base of 2. And we said it would be 2 squared. That's how we get 4. But then this brings back into our power to power, right? Because we've got a power brought to the original power of 5x. So when we have power to power, we multiply the powers. Then we've got our equals. We know this is going to be a base of 2, but this one is going to be 2 cubed. That's what would give us 8. And of course, we can't forget the original power. So it's 3 times 2x minus 1, power to power. Multiply the powers. Now that we finally have the same base, we can drop the base and just worry about the exponents. So I've got 2 times 5x equals 3 times 2x minus 1. So 2 times 5x is 10x equals, and then I gotta distribute this 3. So 3 times 2x is 6x. 3 times negative 1 is negative 3. I want to take my smaller x value, bring it to the larger x value. So I'm going to subtract 6. 10x minus 6x, that's going to give me 4x equals negative 3. Final step is divide by 4. And I have an x equals negative 3/4. Or if you like decimals, that would be a negative 0.75. Either way. as our final answer. And again, you can plug either the fraction or the decimal into the original x values, and you should get the same value on this side as you do on this side. All right, let's do one more problem. Now, you'll notice this one looks way different than the other ones that we've had. Just taking into some observations here, I have a like base of 4 here and a like base of 4 here, but then we've got this weird times 1/16 thrown in the middle here. I definitely don't want to deal with a fraction. So this reaches back into our negative exponent law. So we've got to keep in mind this is 1/16 to the first power, right? Anything, and we touched on that in the exponent video, that if I ever don't see a power, that means there's an understood power of 1. But remember that if we cross the line, we change the sign. Okay, so I could rewrite this 1/16 as, instead of times 1/16, I could rewrite it as times 16 to the negative 1 power. We can cross the line to change the sign. Okay, and if you need a review on that, definitely take the time to review the negative exponent video. Let's go ahead and bring down, since I've kind of taken care of that one piece, let me bring down my other parts. Let's analyze what we have now. I still don't have like bases, but now I've got this base of 16, which is still not the same base as 4. And 4 is definitely my target base right now because I already have 2 that are equivalent to 4. So let me see if I can somehow have a base of 4 and yet end up with an answer of 16. Let's see. So we go into our y equals, we want a base of 4. We're going to put it to the power of x, go to our second table, and see is there any way I can get a y value of 16? And luckily, yes, we can. I've got my like base, so I've got 4 to the x power times 4 to the second power. That's going to give me my equivalent of 16, but remember, power to the original power of -1 means we multiply the powers. Power to power, we multiply. Equals 4 to the 5x minus 7. So now, finally, we've got all like bases. They're all 4s, so I can remove the bases. And I've got an x times 2 times the -1. So remember, when we multiply straight across, I add the exponents. So this is really x plus 2 times -1. It's tricky. In this one, we've had to use 3 different exponent laws in the same problem, and that happens sometimes. So we got to really know those exponent laws. Equals 5x minus 7. Now from here, it's just basic solving. So I want to go ahead and clean this up. 2 times -1 is -2, right? So that just becomes an x minus 2 equals 5x minus 7. I want to take my lower x value and bring it to the higher x value. So I do that by subtracting x. And I've got a -2 equals 5x minus 1x is 4x minus 7, and then I bring my constants together. So -2 plus 7, that's going to give me 5 equals 4x. Divide by 4. And we've got a final answer of x equals 5/4. Or, if you like the decimal version, 1.25. Alright, so if you were to take that and plug it back into your original equation, so you could leave, like when you're doing your check, all you're plugging in is 1.25 for x. So this would read 4 to the 1.25 power times 1/16. You can leave that as it was given to you. And once you type that in your calculator and get an answer, you should get an equivalent answer, the same answer, when you do this side. Alright guys, here's your you try. So I've given you 2 examples here to try on your own. I will post the answer in the video description below. This has been Miss Smith's Math Tutorials.